Hello and welcome to my video on 3.2 on electromagnetism. So first of all, when discussing electromagnetism, we need to start thinking in three dimensions. Therefore, we use X for going into a page and a dot for going out of a page. You can think about shooting an arrow into the page or shooting an arrow out of the page. If you shoot an arrow like a bow and arrow, if you shoot it into the page, what you see at the back of the arrow, the last thing to hit the page is the tail feathers. Okay, the last thing you see before it's gone. And you see that the majority of the flight while it's going into the page. Okay, when it's coming out of the page, what you see is the pointy part of the arrow, the dot, the arrowhead. And that's what you see the majority of the time as it's traveling towards you. Now, we use two different hand rules depending on the situation. And we're going to use these hand rules to help us understand either the direction of the electron flow or the magnetic field lines, et cetera, depending on what's going on. And we're going to have to use the X and dot in order to draw this on a two-dimensional piece of paper. So keep that in mind. So we're going to use two different hand rules depending on the situation. We're going to use the first hand rule for straight wires. Okay. And the left hand rule, so the first hand rule is for straight wires. We use our left hand. The thumb is the direction of the electron flow. The fingers are the magnetic field lines and the direction of the field lines. So you can watch here, if you're watching this carefully, you can watch the field go around the wire. The field is actually wrapping around the wire in blue, whereas your thumb is pointing along the wire with the electron flow. Okay, the second hand rule is for coiled wires, and this time you're still using your left hand because you use your left hand every time you're dealing with a negative charge. Okay, so the electron flow, well, electrons flowing, electrons are negative, that's why we're using our left hand. And for coiled wires, the fingers are coiling around. And so those are the electrons actually flowing in the coil. And then the thumb is the direction of the magnetic field. The direction that your thumb is pointing to the north end. Now, if you Google the magnetic hand rules, you will probably find a whole bunch of answers on other websites or other YouTube videos that are talking about conventional current. Conventional current is wrong. It is what Americans use and what many websites use, but conventional current pretends that the positive charge is moving, but that's simply just not true. Okay, in conventional current, they use the right hand for the first and second hand rules. In Alberta Physics 30, we do not use conventional current. What we do is we talk about the true reality of it. We know that only electrons move, not protons. So electrons moving, that's what we're doing. That's why we're using our left hand, because it's negative. Okay, right hand is positive, left hand is negative. Okay, so already mentioned in the previous, in a previous topic in 2.4, but this is useful again. Current is the rate of flow of electrons, so I equals Q over T. I is the current, Q is the charge, T is the time in seconds. And again, also talked about before, but when battery terminals are shown, we show them like this. Okay, and the smaller side, I think smaller, a negative is a smaller value than a positive. So this is the positive end of the battery. This is the negative end. And so if we follow the wire around, we always know it flows from negative to positive. So you can watch the electrons flowing around. Now, normally you don't draw it like that. Normally we just draw it like this. Okay, now if you're using your hand rules, you can practice on this. Okay, since it's just a single wire going around, you can make your thumb go in this direction. Okay, that would show the electron flow. The thumb is going in this direction. And then you're using your left hand, which means your fingers are going to be curling into the page here and coming back out of the page on the other side. So the blue is the magnetic field, and the green is the electron flow. All right, we have a couple examples that we're going to take a look at for this lesson. What direction would the electron flow be in this first example, considering that the magnetic field at point B is going, in this case, into the page? Okay, so here it's going into the page because there's a dot here, right? It's just a dot. So it's going into the page. So if it's going into the page there, we're going to use our left hand rule. And this is going to be the first hand rule because it's a single wire. And so going into the page there, or sorry, did I say into the page? It's not going to go into the page. I made a mistake there. That's going to be coming out of the page because it's going to wrap around. And so it's going to be your fingers with your left hand are pointing up towards you and wrapping around on top. It's going away from you. On the bottom, it's coming towards you. It's wrapping around kind of in this way. That's what your fingers are showing. Okay, so that's not great because it's kind of a little bit confusing there, but that's what your fingers are showing, wrapping around in this direction. Okay, with that in mind, that means your thumb is pointing this way. So that means the electron flow is in that direction. So example 2, we're going to draw the terminals of the battery below. So the blue battery here. I'm going to use blue to draw it. Okay, I would recommend you try this right now and see if you get the same answer that I do. Well, this is going to be our second hand rule because it's a coil of wire. You're going to use your fingers as the electron flow. Now that's going to be hard to tell, but your thumb is going to be pointing towards the north. So our thumb has to be pointing this way. Okay, with that in mind, that means I've got my palm up, my fingers are curling around. So my finger is going down and then up and around this way. Right? Which means that my electron flow has to be in that direction. So it's going to be a short and then a long, i.e. it's a negative on the left and a positive on the right. So I'm going to just change that so it's blue, but a short and a long. All right, it's just about practicing your hand rules here, guys. So let's try another one. Example number 3. If two wires are carrying current in the same direction next to each other, are they attracted or repelled from one another? Well, we could do multiple different things, but let's just make both wires go into the page. Okay, so these are two wires going into the page, which means that my thumb is going to be pointing into the page and my fingers are going to be wrapping around. So my fingers are wrapping around in this direction. Okay. And it would be the same thing for this other one in this direction. Okay, now here's the thing. It's always pointing towards the towards north, right? It's always pointing towards the north end. It's wherever the north end of the compass would be. So this is north, this is south, and you can see that this other side is the opposite. or that's the, yeah, it's pointing towards the south end, but there is no south end. It's the north end pointing towards the south end. Kind of confusing to word that. But essentially, you can see that the two sides are going to be opposite. Hopefully, you can tell they're going to be opposite. And so they're for sure going to be attracted to each other. Okay, so if they're carrying current in the same direction, they're going to be attracted. If they're carrying current in the opposite direction, they're going to be actually repelled from each other. Okay, let's look at example 4. What is the time that it takes for a 4 coulomb amount of charge to flow through a wire at a specific location when there is a measured current of 15 amps, which is a regular Canadian breaker or outlet? So with all that in mind, I believe that our formula was I equals Q over T. Okay, so we're looking for the amount of time. So we're going to just rearrange this. So T equals Q over I. So 4 coulombs of charge and 15 amps. So we're going to get a decimal answer of 0.2666 repeating, or in this case, 2 sig digs, 0.27 seconds. All right, I hope that this video helped you understand some of the basics of the first and second hand rules about straight wires and coiled wires. Hope this video helped, and good luck.